Welcome back to Mr. C's Biology. Today we are talking about the cardiac cycle and how electrical activity in your heart causes it to pump in a rhythmic, ordered way by itself. So you don't have to think about contracting the muscle inside your heart every time your heart beats, thankfully. And the way it does it is using two pacemaker regions, the AVN and the SAN. So the SAN stands for the sinoatrial node, AVN stands for the atrioventricular node. And we'll talk about these terms in a moment a bit more. Firstly, we've got a few more key definitions that we need to know. Firstly, we're going to talk about systole. So systole is the contraction of a region. It's where this region is going to be depolarized. I'll explain what that means in a moment. And it's when, therefore, these muscles contract and blood is forced out of that area. The opposite of that is diastole. So diastole is this relaxation, that it's repolarized, the muscles are relaxed, and that's where an area can fill with blood. Now, depolarization and repolarization are terms to do with charge, the electrical charge around these cells. Depolarization is where this charge changes and causes the muscles to contract. Repolarization is the resetting of the charge, winding it back to zero so it can contract again at a later stage. Now, the first step where we start off with for contracting the heart is called atrial systole. Atrial systole is the contraction of the atria, and it starts off in the sinoatrial node, the SAN. Now, the sinoatrial node is called that because it's in the sinus, or the opening, of the atria. And so we have this SAN, and it starts off by stimulating and sending a signal that causes a wave of depolarization across the atria. Now, you'll remember depolarization means contraction, so there's this wave of contraction across both of the atria that causes them to contract, force blood out of the atria, and we know that when blood leaves the atria, it goes to the ventricles. So this atrial systole squeezes blood into the ventricles, and that's the first stage of the cardiac cycle. As an aside, when it finishes this first stage, there's a layer of non-conductive tissue, so tissue that won't allow this wave to continue. Now, that's between the atria and the ventricles, and it basically means that this wave of contraction going across the atria doesn't spread to the ventricles quite yet. It needs to do that in a regular, ordered fashion. If it didn't have this non-conductive tissue that only slows it for about 1/10 of a second, then what would happen would be that atria and the ventricles would contract at the same time, and blood wouldn't as easily be forced out into the arteries. So the second stage of the cardiac cycle is called ventricular systole. So you may be guessing, well, the ventricles are going to contract, systole meaning contraction. And now this wave of depolarization that is spread from the SAN all across the atria triggers this one part called the AVN, the atrioventricular node. Now, it lies in the gap between the atria and the ventricles, and is the only bit of conductive tissue in between those two. Once it's triggered, it sends a signal down the septum between the two ventricles through some fibres called the bundle of His. Now, this bundle sends these signals down all the way to the bottom of the ventricle, to the apex, the point of the heart, and then sends that wave of depolarization, the wave of contraction, up from the bottom through some fibres called Purkinje fibres. So these fibres go into the muscle of the heart, and they cause the heart to contract from the bottom up. Now, the reason that happens is because we want to contract the ventricles and get the blood into the arteries. And the arteries, if you've ever dissected the heart, or you've checked out my dissection video on my channel, then you'll see that the arteries are at the top of the heart. The third stage of the cardiac cycle is diastole. So all these chambers relax. They repolarize, prepare for the next cycle. And the repolarization is the resetting of the electrical charge. They've been depolarized, they need to reset so they can depolarize again when the next heartbeat comes. And they relax so that they can fill with blood from the veins. Now, that is the basics of the cardiac cycle. And I've got a couple of questions for you to think about, and you can put your answers in the comments if you'd like. Firstly, how do you think a pacemaker works? A pacemaker, remember, is something that's an electrical device surgically inserted into someone who has a heart rhythm problem. How do you think that might work? And secondly, have a look at an ECG trace. It's the classic thing that we imagine about a heartbeat. It's the sort of thing you might see on Casualty. And it's a way of measuring the electrical activity in the heart and putting it on a graph. So can you match up the electrical activity that we can see on the graph with what we now know about systole and diastole and the depolarization. That change in charge is an electrical activity. So can we match up what's happening on the ECG with what we know to be happening in the heart? That's everything from me for today. If you've got any questions, please put them in the comments. I'm really happy to have a discussion with you. And if you've enjoyed this video, thanks for watching. Don't forget to click subscribe, and I'll see you next time. Thank you.